Hi everyone. Today I am going to explain about servo motor. Servo motors are generally known as control motors. Their power ratings vary from a fraction of a watt to a few hundred watts. They have a high speed of response and generally operate at very low speeds. Servo motors can operate from both DC and AC supplies. These motors are used in feedback control systems as output actuators. The DC servo motors are separately excited DC motors or permanent magnet DC motors. The speeds of DC servo motors are controlled by varying the armature voltage. The armature resistance is very high and a step change in armature voltage or current produces a quick change in the position or speed of the rotor. The AC servo motors are basically two-phase squirrel cage induction motors used for low-power applications. The rotor has high resistance and small diameter to length ratio to give good accelerating characteristics. They produce high torques at all speeds including zero speed. Figure given shows the connection diagram of a two-phase servo motor. One of the stator windings, called reference winding, is excited by a fixed AC voltage VR, while the second winding, known as control winding, is excited by the voltage VC. The two voltages must be in synchronism, which is a necessary condition for production of torque. Therefore, the two voltages must be derived from the same source. The control voltage is fed to the motor through an amplifier. Moreover, the two voltages must have a phase difference of 90 degrees. This phase shift is usually obtained by using a phase shifting network in an amplifier circuit. The 90 degrees phase shift can also be obtained by adding a capacitor in series with the reference winding. When VC leads VR by 90 degrees, rotation in one direction is obtained, and when VC lags VR by 90 degrees, rotation in a reverse direction is obtained. Since the torque is a function of both VR and VC, changing the magnitude of VC changes the torque developed. Next we will see drag cup rotor. When the rating of a servo motor is only a few watts or less, inertia can be decreased by using a drag cup rotor. This is in the form of a thin metallic cup. The iron core is stationary. Since only the metallic cup is the rotating member, the inertia is very small. Thank you all. For more updates, keep on watching Electrical Engineering Simplified.